Yellow.
Okay. Yep. Good.
So our topic was predicting disability, and really the premise was, can we predict disability with just demographics or population sort of statistics or percentages? And so really we wanted to try and be able to predict the percentage of the population receiving disability in the state. Again, the same thing, using demographics, income, percent female, race. We had 4 or 5 different percentages that we used, education, things like that. To reiterate, we're not trying to predict who's receiving disability, we're just trying to predict the percent. So any of the analysis we did, we couldn't say if it was this race that was receiving more disability because we didn't have that data. The data that we pulled from data.gov, and that had all of our disability data that it talked about number of people who filed, the people who received favorable outcomes or were approved for disability. And then the other portion of our data that we combined with it, we used a third-party website that pulls data from 2013 census predictions. Again, because it wasn't a census year, it was still based upon their estimates of what it would be. So we had only to 0.1% accuracy, because that's all that they would predict from the census predictions.
Okay. So we have a number of different variables. We're going to list all the ones that we looked at. We didn't include all of these in our final model. So this is what we were trying to model, the percent receiving disability. We have a percent female. We didn't do the percent male because they're just the opposite of each other. We also broke it down by race. This is our first one. White, the one thing that was kind of interesting about white was it actually included the Hispanic and Latino within white. So we went ahead and went and take a note of that. So you're not going to see any Hispanic.
It does explain it there because it deals with the origin. So if you're Hispanic, you're from Spain, that would have been your European country, was your country of origin.
And then we had African American, Native American.
And the Native American also includes Alaskan. So it gets, there's really technical definitions on all of them, which was pulled actually from the census.
And then we have, let's see, Asian, and then multi is so they have more than one. And since they only had to check different boxes, that includes all of them. So if you went to all the different races for a given state, if you went through each one, the different percentages, they would add to be around 100% with just these up through multi. Oh, and then we also have Pacific Islander too. Yeah. Then high school grad, that is the number of people, a person that graduated from high school, and then the person that earned at least a bachelor's degree or higher. We also looked at the number of veterans, both the number and the percentage of veterans, and then also percentage of population that in a state that owns their own home, and persons or the family side, the number of people in a given household. Median income for the state, percent poverty would be the percentage of people below the poverty line in a given state, and then adult filing. This one was kind of interesting because I guess we can get into this one later, but adult filing was very similar to the one we were modeling, so that one we had to do some work on. But actually, I think that was the one we just completely got rid of later. So we tried it several different ways. The first way we did it with no data transformation at all. We just used the percentages, converted them all to, some of them that we pulled off the Census Bureau were like 4 point something, they were like the number out of 100, and some of them were out of 1, so we converted them all to be out of 1. So we did it just with regular. One thing that was really interesting about this was we started with a stepwise selection model, and that pulled one that had like 4 variables in it. And then we tried looking at like CP, Mala CP, and we looked at the AIC and all of that, and that picked a different model, which I thought was really weird. You don't see that very often. But it actually picked 2 different models for this. So yeah, then we removed adult filing during this stage.
And part of it, why this first one didn't work is because we had a bunch of collinearity and correlation issues. Part of it, we think, was just by the nature of the data, because we were dealing with a lot of percentages, and we're still dealing with the state. But our next step was to just try to transform the data to get it to better fit what we were wanting. And so this was the next step, data transformation. We tried ArcSine. Basically, we were trying to get our percentages, which were a lot of in like the 40 to 50% range for a lot of stuff, to get those to be bigger, to have a wider variety. And so we did the ArcSine of all the independent variables, so percent female, percent white, all that stuff. It didn't actually fix anything as far as collinearity or correlation, but the negative side of it was it ended up reducing how good it was at predicting significantly. Some of those were down in the 0.5, 0.9 range. So that didn't end up working out. We tried, again, different combinations like natural log ArcSine. We tried ArcSine squared, different things, and none of them tended to fix the issues we're actually trying to address. I guess that's what that's saying. But our one that we decided on, and actually Caitlin had the idea of just doing the dependent variable and switching that.
So we left all the other percentages just the same. This is the only one we transformed, was the percent receiving. And that one was nice because it barely touched our R squared, but it did fix some of our collinearity problems. Race was still collinear with the intercept, but that could largely be due to the fact that we were dealing with percentages, all very small. But everything else, all the other variables that helped fix that for it, helped bring our variance inflation factors way down. So so it makes the model these better, easier to draw conclusions from when there's less collinearity between the variables. So that's why we decided to go ahead and switch to this one, because it seemed to fix the problem without hurting the model predictability very much. So these are the 7 that we settled on then. These are the dependent variables. This is the one that the Malus CP and the AIC chose, but not the stepwise. So this is when the only one of the race ones that was in the model was African American, which I thought was kind of weird, but that one was significant. But we don't have any of the other race ones in there that it was correlated to.
And so a lot of these, kind of make sense. I guess a couple of these make sense as to predicting disability. Obviously, the more eligible adult population you have, you're going to get more people applying for disability. It's going to increase it. The percent in poverty, I think, also makes sense, because you end up, if you don't have money, you're going to look at some source of being able to get money. We're more likely to probably reach out for those avenues and utilize those. Some of the other ones became a little bit more tricky, but we'll go into that in our conclusion as to why it's trickier. And then the dependent variable, again, like we said, we transformed it by using the ArcSine. The summer statistics on that, the R squared was 0.76, the adjusted was 0.7322. Our largest residual is 0.0203, and our smallest is 4.40464. So incredibly small, but we're also dealing with percents of the population that are between, it could be 1 to 2%. Some of them are a little bit higher. I want to say maybe in the 4 to 5% range. So having a residual that, although it looks pretty small, it is pretty significant when you're dealing with such small percentages.
Okay. For the assumptions, they weren't quite as important because we're using every single state and the District of Columbia, so we're basically using the entire population of United States states. But we did take a glance through these graphs to see what would the PP plot and histogram of the residuals would look like. All of the residual plots for the 7 variables, there were some major outliers, but otherwise they looked pretty random, and we'll get to those later.
And the full model fixed this, so it looked more normally distributed.
Yeah. The full model was great for all of these, but
that's also using 14 variables, which I guess the goal of regression is to bring down the number of variables.
So these are some diagnostics that we ran once we selected our final model with the 7 variables. So we checked the Cook's D and the hat values to see if any of the observations, any of the states would be flagged. And we flagged quite a few, and we go into more detail on why we think they were flagged and everything. And also the studentized residuals and deleted studentized residuals flagged some. They flagged the same because the cutoff values are very similar. So one of the observations was Alaska that was flagged. And it seemed that the percentage of the females was farther away than the rest of the data's residuals. And that's probably because, the state population is smaller than other states and there's less females in that state. So I think that was the reason it was flagged. California was also flagged. It has a larger population than most states, but it did not seem that extraordinary that it was flagged. And District of Columbia had a higher percentage of people with a bachelor's degree. That makes sense because DC is home of politics and kind of needed education to survive there. And then Hawaii had a larger percentage of Pacific Islander, Asian, and multi-race percentages, so that just goes with the culture and origin of Hawaii. And then New Hampshire and New Mexico were flagged, but none of the percentages seemed like out of the ordinary, so we weren't sure why it was, what reason SAS flagged them for. And then Nevada was flagged because it had a lower percentage of veterans than most of the other states. Oh, and Utah also was flagged. It had a higher people per household percentage, and I kind of suspected that was because of the high percentage of Mormons who live in Utah, and their faith, they typically value children and tend to have more children than other families. And West Virginia, they had a lower percentage of bachelor's degrees than most states. And then the median income and poverty were low, but not too unusual. And this might be because West Virginia has a higher elderly population than other states.
And we ended up, we didn't remove any because, again, we're dealing with the full data set. You can't really remove DC from the United States. I'm sure it would be nice for some people, but so we had to leave them in, and really that's why we tried the transformations to make the data look like what we want it to look like. And then here are a few examples. We thought we would do Kansas because we live here. So the dependent variable, we said a point, so we're predicting to get percent that's on disability. And it is about 5.61%. Our model predicted 5.46%. And I think the model did pretty well actually predicting it. And you can see our standard error and our confidence limits and the mean as well as the predicted and the residual. Yeah, I guess what you see is what you get on that one.
Wisconsin, we put on here because this one had the lowest residual. Remember at the beginning we had one that was like 0.0004 or something. So this one, that was Wisconsin. So really we rounded to 4 decimal places here. The dependent, the actual versus the predicted were basically exactly the same. So this is one that the model did a really nice job predicting.
And the actual residual was like, it's 4 zeros followed by 4.
Yeah, it's at the end there.
Mm-hmm. Yeah.
Right there.
1, 2, 3, 4, and then 4, 6, or 4, 3.
Yeah. And then this one was the one with the really large residual with like 0.0203. And actually this was kind of interesting because most of them, the actual fell within our confidence limits and all that. This one, we were really far off from what it actually was. Actually, even the actual one wasn't even inside of our confidence limit. So that one was like way off compared to almost everything, all the other states.
And you'll notice actually significantly higher. Can you go back one? Like you're at 6%. Kansas was at 5.5. Going to West Virginia, you're double, almost double that. And part of it, again, I think it's good, if you look at the data, it's going to be like percent in poverty. But analyzing that stuff, like I said earlier, is kind of tricky, which we'll kind of go into. But we still undershot it, which I thought was interesting. So
Yeah, and we suspect, West Virginia having higher population of elderly people, so it makes sense that their disability would be a bit higher.
and actually know somebody who works for disability, and there's different rules that apply when you're above 55. So it's actually easier to be approved if you're 55 or older. So that would play into very directly your percent that's receiving disability.
And this is just so you can see on our predicted versus actual plot, you can see the different points here. So we have Kansas, we have Wisconsin, and then we have West Virginia. So West Virginia was the one with the really high residual. That one was the one with the lowest residual out of all of it.
And our model, when we did the arc sign, we're able to, our model, some of the things that we were concerned about, although it was good at predicting, the high correlation causes concerns when we're trying to interpret parameter estimates, meaning because the percent female may be high, that may also affect like the percent in poverty, like single moms or things like that, because you have a disproportionate like male to female ratio or number of kids in a family. Again, with a single mom, that can affect a lot of stuff, but there's no real, this doesn't tell us the root cause of what's actually going on. So that's one of the things that we struggled with actually interpreting the model to see, I don't want to repeat myself, but like the root cause of what's going on. When we determined those more variables are needed, especially ones that are not percentages or ones that give us a wider range of percentages. And really the best thing to do would be have the demographics of people who are approved instead of just trying to base it upon the total population of the state.
Any questions?
I had a question from earlier, which I have forgotten, but while I'm thinking of it here, one of the things that you have to understand with this kind of analysis is it's state level variables only. There's no per person variable here. A better data set, which doesn't exist, would be every single person, whether they got disability or not, and what are the demographics of that person. Because
And that's what we were requesting here, but
Yeah, each of our observations represent a state, and that state's population
And-
had disability. For
I'm
people who-
drawing a blank on the name of the bias, but there's a bias that can come in when it's possible that everybody, like the demographics of West Virginia are different, but that has nothing to do with the people who went on disability in that state. Maybe they, You know what I'm saying? So that state was different and their disability was different, but there's no guarantee that there's a causation effect.
Yeah.
Yeah.
When it's a high level of data.
And because of kind of like what you were saying, we were actually pleased to get around 77% of predictability, or can be explained by the model, because what you're trying to predict is something actually pretty hard, and this is why interpreting it becomes harder than just saying, this is a good prediction. It's going to be close about 77% of the time.
One thing we were also trying to do is we were trying to stick to things that you could, statistics that you could get at the beginning of the year to try to predict the disability throughout the whole year, so like you could do it ahead of time, which is why we removed things like adult filing, which would be a better predictor. But you won't know that until you already know the number of people who filed and stuff too. So that also really limited what we could use. I mean, you could get a much better model if you could use other things collected later to this.
So do data sets exist per state that are person to person? Like,
It would be considered confidential information and you couldn't get it in public use data. The state would have data like that and they would do their own analyses, but it'd be confidential.
And I think, because even the person reviewing the actual disability claim, I don't think they have access to the stuff that even you're talking about, like sex and like race and things like that, because it's not needed for what they're doing. So,
And I remember the other thing I was going to comment on, it's not really a question, but West Virginia stuck out as sort of an outlier, really high rate of disability, but okay, what is disability? That's when people, like they get injured or whatever on a job they can no longer work, right? What's one of the big industries in West
coal
Virginia?
mining,
Coal mining, that's two.
And it has a very high disability rate in that industry because it's backbreaking work. There's all kinds of health concerns. There's cave-ins, all those things, and so.
That's true.
and see, that's like when we went to trying to like interpret what it's meaning. We didn't know if it was that, or because they also have a lower degree or lower percentage of bachelor's degree. So is it because a lot more people are in the backbreaking labor, or is it just that the labor, like the coal mining, there's going to be a lot more people injured compared to somebody working in like a warehouse?
So that's, I don't know your data set or what was available to you, but that would be something to look into is, and again, it would just be statewide statistics, but what are the main industries in that state? The main types of professions in that state. If they had this percent of our population are college professors, this percent are coal miners, this percent, some of those might turn out to be really important figures in disability, but I kind of doubt they had that.
Yeah,
It'd be
that would have been
interesting
hard to
next step.
find. That would be cool.
But then we have to do 50 different,
More than
data sets.
50, yeah.
or 51 data sets.
Mhm. Yeah.
You persons per household was one of the variables getting them all, which way is significant?
We can pull it back up again. If it's positive, then it was higher.
Yeah.
Oh shoot, didn't put that.
model in there.
We didn't actually put it in here from SAS. I think, if I remember right,
Is that number of people per household?
Here, persons per, so it'd be
that's a
So it's like,
mom, dad, 2 kids, 4.
yeah.
Mhm.
If I remember right, the more,
variables in your final
I think,
model?
sorry, say that
Are
again.
those the final variables you used in
Yeah.
the model?
yeah,
Yes.
those are the final 7.
And we ended up having, after transformations, we looked at like